Hi everybody and welcome to another live episode of AWS Bytes. Today we're going to do something a good bit different from what we've been doing in the last few episodes. First of all, I'm Owen and I'm joined by Luciano again. We are still on our mission to build a file sharing app in AWS and live code it all for you and make all the mistakes and see how it goes. And we've had a lot of fun over the last couple of weeks building up the back end. We also built up a small CLI at the front end. And we ended up spending quite a lot of time on putting in place some security so that people couldn't upload anything to our bucket. So the last few episodes were focused on device authorization. And we got quite deep into the OAuth to device code flow. It started to take quite a lot of time. So what we've decided to do is accelerate the rest of that process for you and get on to something a little bit more exciting. So what I'm going to do is I'm going to share my screen. We'll talk about the changes that we didn't get to complete last week. We put it all into a pull request on the weshare.click GitHub repo. So you can see all the changes there. I'm just going to go through them fairly briefly. I'll show you how the backend works. We'll do a quick authorization end-to-end flow. We'll log in. We'll get some access credentials. And I'll just demonstrate that using Postman. Just talking to the API. Luciana's just shared the repo URL there, so you should have it in the chat. But yeah, if you have any comments, questions, anything else you want us to change, any suggestions, please leave your comments in the chat. We'd love to hear from you, and thanks for joining us. So let's share what we're doing here. So you can see the diagram we have of this beautiful OAuth to device code flow on the left, and we've got the pull request on the right. So I think in the last episode, we got as far as doing the verification URL. So you log in with the CLI, you post to the device authorization, it sends you back the device code and the user code. The user code is that 8-character code that you have to enter when you log in on the other screen. And then the next thing is that you have this verification URL. So we implemented the verification URL where you go and enter the token, this user 8-character token in your web browser, and that would then redirect you to Cognito, which is the identity provider, to do the actual login. The two endpoints we didn't implement last week were the polling one, the one that actually gets the token, and the actual callback handler. So the callback when the IDP redirects you with a code or a token. We didn't implement that. So let's have a look at those. And I'm going to increase the size of the font in this pull request. Maybe what I'm going to do is just increase the size of that altogether. Yeah, so we're looking at the IDP URL. So when we get redirected, you'll remember that we had DynamoDB and we were storing the device code, which is the really long random identifier for this authentication session. We were storing the user code, the 8-character one, and we'd also just generated this CSRF token called state, which was another identifier for the authentication session.
Can I make a quick suggestion? If you click on the cog there just above the file name, I think you can change it to split mode into unified.
That's a good idea. Great suggestion.
Oh, it needs to reload. Okay.
Okay, I can still get rid of the file tree. Brilliant.
Okay, that should be a little bit more readable.
Yeah, in the comment, we added some more comments as well, just specifying which part of the spec it's implementing. There's some other minor changes, but I'm just going to go directly to the IDP callback. So when we get an IDP callback, this is when you go log in with Cognito, it issues a code and it calls your callback, your redirect URI. So we need to pull out the code and the state from the query parameters. There's also a possibility that they can give you an error in this callback, so we need to process that too. We've got some error handling in here, but let's just jump down to the main logic, the happy path in here. So when we get back this state parameter, then we can use that to look up the record in our table. So we just do a DynamoDB query for that. And we check that there's a value in the database. And if there is no value, we return an error. Otherwise, we'll proceed and we'll say, okay, we've now got a code. Right, so if we've got a code, that means that's the first part of your two-step process to get a token. First, you get a code and you exchange the code for a token. Well, we're just going to store the code in the database. So we do another very beautiful DynamoDB update expression, which will store the code or the error, depending on whether it was successful or not. That gets stored in the DynamoDB table. And again, we have this condition expression. So we just have a check that the state transition here is valid, that you're going from the previous state, which was verified, to the new status, which is going to be either code issued or error. And we'll make sure that the session hasn't expired as well. So we do that update, and if the condition check failed, we again say this is an error, it expired. Otherwise, we will return a response to the user, and the response to the user, this is still a web page that they're looking at here, will return either a 200 saying, thank you, you're done, go back to the client, or we'll return a 400 saying, there's an error, and we'll provide the text of the error. So maybe you entered the wrong password, or your account has been disabled, or no such username, whatever it is that comes back from Cognito, that's what we'll display.
Awesome.
So that's the IDP callback. Will I quickly look at the token one then?
Yes.
The token one is probably one of the most simple ones in here. So what we're doing here is this is the post request. So Luciano is going to be implementing the request to pull the token. And this is as soon as you start your device authorization session, you know that the user might be going to their mobile or another device to do the login. So you just have to wait until that's complete. And you do that with a polling API. It's a post request to /token. And we're basically taking the device code and we're doing a lookup in the table. And we're just going to wait until there's a token in there. So we'll look at the values in that table. If it's expired, it's expired. We'll just return right away. But then we look at the various states that might be in that table. So either it's pending or it's verified, in which case they've entered the 8-character code, but they haven't completed the login yet. The successful one we're waiting for is actually code issued, because once we have a code issued, we can exchange that for a token. And if the code has been issued, then we'll go ahead and fetch the token. And that's another request to Cognito, which would basically saying, I have a token. This is my client ID. I want to swap this code for a token. And we'll just send that request off to Cognito to its token URI, and we'll get back the OAuth 2 token response, which will have our ID token, access token, refresh token, and an expiry.
Mm-hmm.
And that's it. That's the final step, actually. So this is the final poll where the token gets returned with the ID token, access token, refresh token back to the user. And then we can start using this access token in the request to create shares. Now there is, of course, once you have an access token, that means you can protect the API. Our API was completely open to everybody up until recently. So let's look at how we protect it. So in the serverless.yaml for the backend, we can now define an authorizer. This is done slightly differently depending on whether you're using a HTTP API or a REST API. With HTTP API, it's got a very generic, extensible way of doing it, just based around the JWT or JOT standard, where you just provide the issuer URL. That's your IDP's URL, and in our case, it's Cognito. So you'll see plenty of examples out there in the HTTP API documentation for that.
Yeah, I suppose that has the advantage that you could be using also, not necessarily Cognito, but any other compliant OIDC provider, right?
Yeah, exactly. Yeah. And it'll check the signature. The standard also has, I can't remember the name of the standard. Is it like JWKS or something, where you can get these
key sets?
Yeah. So you can get the certificate to validate the signature. Basically, is that
And also
how
you
it works?
could have different keys to sign. Sorry, you can have different public private key pairs,
Okay.
and they have an ID. So every token will have an ID. So potentially you can rotate keys, you can do all sorts of different things. And then the protocol codifies all of that stuff. So given a JWT token, it checks what's the ID of the key used for that token, and it's able to download the public key from the provider, and that way it can check the signature.
Okay. Interesting.
Yeah,
Yeah,
if you
it's
ever
interesting.
needed to implement all the stuff yourself, it is actually quite interesting and you can learn a lot. But these days, there are so many implementations that you just kind of assume it works. So probably not many people have looked into like the internals of it.
Okay. So this is how we define our authorizer. It would be slightly different in if you're using an API gateway, REST API, because it's Cognito specific in that case. A less generic approach, but you define your authorizer in the serverless framework. At least you define it up in the provider section, and then you use it in each of the APIs you want to apply that authorizer to. So here we've got our post API, and we just specified this is the authorizer we want to apply. So once we deploy this, and we have deployed it now, if anyone wants to go to post a request to weshare.click/share, you should get a 403 because you don't have a token. I'll just, will I walk through the flow actually on Postman, Luciano, and then you can take over the front end. Okay, let's do that. So let's switch over to Postman, and I hope this is big enough. Ooh, too big. So I'm going to start off with the first request, which is requesting a device authorization. So I'm going to click send here. This is a post request. I don't think there's anything else, right? This is just a completely anonymous request.
I don't know if you
And
remember, anyone remembers our previous episode of the stream where we showed like the Amazon Prime TV version of this. So you can imagine this request as when in your device you say, let me log in, and you get that human-friendly code, like 6 or 8 digits or something like that. And basically, from our perspective, like starting from a CLI, we trigger this HTTP request to initiate that flow. And you can see that in the response, we have that user code, which is like the equivalent that you will see in a TV screen or in the device where you're trying to do this kind of login.
yeah, exactly. Yeah. So I'm just going to switch to the poll one. So now we've started this. The client is going to start polling right away before the user has run to find their phone and trip over the dog and come back to enter their code. So we need to take that device code that we got and we need to pop that into our fetch authorization token request. So that goes into the URL encoded body. And we click send, and we should get back a 400. Where do I see the?
It's the green one.
Smaller.
It's the
body.
green label. Oh, yeah. Okay. Yeah, I guess there isn't really a body, right? Because it's just... Oh, no, there is a body that is like pending or something like that. Yeah.
Yeah, we get back the authorization code. So we're going to do this every 2 seconds. And we're going to get back authorization pending until we complete it. So let's go back and pretend that we're a user, and we'll click into this verification URL. I was already logged in, so it was a little bit too quick.
I think there is...
I should just use a private window or an incognito session.
Yeah, well, we can do it again later. Or probably
we can do it again.
Yeah.
So I can just go back to Postman anyway, and I can fetch, I'll do my fetch request again. And now I have ID token, access token, and refresh token in my JSON. So maybe what I can do is just grab the ID token. And I'm gonna open up a shell. And
Did you
I'm going to
install
use...
JWT info?
I did, after you recommended it the last time. I've got it all ready to go, so I can just paste that in, and it will decode and show the payload of the identity token. So we can see my Cognito username, we can see my email address, we could see the audience, which is the client ID. So we have everything here for the identity, and we also have our access token, which we can pass to our APIs, and that will have similar set of fields actually, but it will not have the email, doesn't have the identity related pieces.
If you don't like CLI, you can also use jwt.io, where you can just copy paste any JWT and it will decode it and show you the payload.
Yeah, and there's a browser extension as well, right? It does the same thing. We could try it again actually, just to try it in an incognito window. So let me just try that, just to show how the full flow works. So I'm going to do new private window. Okay, so now we can see our login page. This is still the Cognito page, the Cognito hosted UI. We've just uploaded a logo and done some very basic CSS customization. You can look at the Cognito documentation to see how that's done. And I'm just going to enter my username and password with the help of LastPass, and I'll sign in, and then it brings us back to our redirect URI, and you can see the code and the state in the query parameters.
Yeah, and the message was just basically saying, go back to your client, right?
Yep. So again, I'll take this device code and I'll pop it in here. And I get another token. But what we can also do is, in fact, maybe I'll just do one last quick demo before handing it over, which is just to try this on another device. See if it works as designed, this device authentication flow. Imagining that we're a smart TV, or that we're actually using the weshare CLI on like an SSH session to a remote server, and we don't have a browser on that machine that we can use. So I've just gone to the verify URL. Oh, actually, I have to enter the query parameter because we didn't create a HTML form for that. So I'm nearly there, and I'll show you what it looks like in 1 second. Let's hope the demo codes help with this. 28D2. Yeah, this doesn't work for me at all. Oh, it defaulted to HTTP on this browser. Why did that happen in 2022? Aha! Okay, in this case, it says the code is invalid. Maybe it expired. Did I enter it wrong? I don't think I did.
Meanwhile, I'm going to say hello to a few people in the chat that are saying us hello. We have Davide, Alessandro, Shubham, and Manuel. So thank you everyone for joining. Feel free to send us your questions or comments, or especially suggestions if you have one.
Okay, I'm going to enter the last character. Hi, everybody. Thanks for joining us. Yeah. It's also saying it's an invalid
I wonder if
code.
they do any like IP checking or something. Are you in the same Wi-Fi?
I mean, this is still our URL, right?
Oh, we also
So it's
have
still
Paul.
in our code.
Hello, Paul.
Hello, Paul. Oh, I know what it is. It's just my copy-paste error. I forgot to put the query parameter name.
Oh, right. Okay, that's something we might need. Yes.
Okay, and let me see if I can show people. It has brought me to the login form here. So I'm going to let's take this device code, stick it into our token request.
And it should tell you pending until you actually complete your login on your mobile phone, right?
Yep. Exactly. So I'm going to ask LastPass to help me again here. So I've got my username and password popped in here, and I'll click sign in. And the message I have now on screen says, "Thank you. You can return to the WeShare client." So then I click send, and then I have my tokens. So
nice.
hopefully we validate the case that this would work for your amazing new smart TV application as well.
Yeah, so just to summarize at a very high level, what's the flow? So you can imagine that basically we are going to be doing from the CLI, right? But you can imagine, again, the case of a smart TV is probably a more common use case that you might have seen when using, I don't know, Amazon Prime, Netflix, whatever. Basically, the idea is that you open a specific page where you want to start the login flow. In our case, that's going to be a post request, the first one you see there. That page is going to tell you, this is your user code that you're going to need to complete the login. And this is a URL where you can go with any device that as a browser and allows you to go to the internet to actually do the login. At the same time, it's also creating not just that user code that you are seeing, but also another kind of longer code, which you can imagine as a session ID. So it's kind of creating a session that is not authenticated yet. And we can use that session ID in the background. So there is a server somewhere in Amazon Prime. In our case, the CLI itself will be doing that is constantly polling that session to see, is the user done yet? Did they authenticate correctly? And of course, eventually there is a timeout, but it's going to keep checking for a while to give the user time to actually complete the login. Meanwhile, the user opens the device and that URL, enters the 6 or 8-digit code, and that way they complete their own login and they authenticate that session. The server or the CLI keeps falling in the background, and at that point it sees, okay, that the session is completed, is authenticated, sorry. So we can use that information to actually exchange a token with the identity provider. And at that point, we can save the token and we can keep using for future interactions with the user, if it's a front end, or from the CLI when the user is starting a CLI command again. Did all of that make sense?
Perfect.
Or did I miss?
That makes sense to me, yeah, but everybody let us know if it doesn't. I think it'll also make sense when we implement it from the client side, because I think, I'm looking forward to this part. I think this is going to be the fun part. I don't know if you agree.
I can try. No promises, but yeah, happy to try.
Well, we won't have to deal with any CloudFormation this time. So, I mean, last week people had to sit through us creating like global secondary indexes in a DynamoDB table with CloudFormation. So,
yeah, that might not be very fun for most people. Okay, so let's do this. Let me make this a little bit bigger. So last time, let me actually quickly show you what we did last time. So in our repository that we have somewhere in the comments, you can see that we have this kind of monorepo structure where we have the 3 stacks that we created for deploying all the infrastructure, the authentication, the backend, and the domain. All of them contain all the serverless code with the serverless framework, CloudFormation, and all that kind of stuff. Then we also have the CLI package that is the one that is not really deployed. It's something that eventually we're going to be publishing on NPM as a package. And you probably can do an NPM install global weshare. And at that point in your system, you have this weshare client. So this is literally just a binary application, quite standard for Node.js. And we decided to use Commander as a utility package for defining all the commands that we support, all the arguments, all the options, and so on. There are many other options. We are just picking the ones we are familiar with, but this is not to say that this is the best option. Actually, if you have any suggestion, they are all welcome, so please send them our way. So, what did we do here? The first version, the one that is already available in the repository, doesn't know anything about authentication yet. So it is assuming that our APIs are totally open and it's just gonna support the upload use case, which is basically send a post to a specific API, gets back a pre-signed URL from S3, uses that pre-signed URL to actually upload the file, and at that point we have a weshare URL that we can send somebody else so that they can download the same file. Meanwhile, Alessandro is telling us that Commander is the best one, so that reassures us, or at least me, that we did a good choice. So that's good. Thank you, Alessandro.
I believe it. I've only got experience with Yargs, and I've always found it confusing.
Yeah, I think it's definitely...
Maybe that's just because you need to invest the time, which is often the case when you don't like tools.
Yeah, I think Yargs is definitely more powerful than Commander, but it's also a lot more confusing to understand everything and organize your code and read the documentation and so on. So I think Commander here, it's the perfect balance.
Quick one, Luciano. Do you want to merge? Should we merge that PR with the backend so that you can start applying the new changes on top of it?
We can merge it, but I think we already deployed that, right? Behind the scenes.
We deployed it. Yeah, I'm just wondering for your commits.
Oh yeah, that's fair enough. Yeah, I can do a git pull. Do you want to merge it or should I do it?
Yeah, I can click merge here. I've got it in front of me.
Okay, I'm ready to do a git pull.
And this is going to merge to the weshare.click main. Done.
So I should pull from main, right?
Mm-hmm. Yeah, it's main on the weshare.click. Yeah.
Okay. Ooh, conflicts. What kind of conflicts do we have?
Ooh.
Why is that? I am in this git replace auth in the device auth branch.
Device auth branch was a different branch. Maybe.
Right. So which
you want to go to main first anyway, I think.
Point. Okay, done.
Device auth was one of our. Yeah, here we go.
Cool. So now we are.
That makes sense.
And you just merged.
We're on the same page.
Yep. Okay. So I can do another branch checkout. Call it, I don't know, CLI out. Is that fine?
Sounds good.
Cool. Okay, so what we were saying is that this current incarnation of the CLI doesn't know anything about authentication. So the current command that is support is only the upload command. And the way you use it is something like weshare and specify a file. For instance, we can say here thumbnail.png, which is a file we have there. And it did fail because it's unauthorized, right? It doesn't know anything about authentication. So it's trying to call the API without authentication header. And the API now that has a fully fledged authentication system is saying, sorry, not allowed. You need to be
working as designed. Cool.
So now the idea is that we can create a new command called weshare login, which is going to start all the flow that we just described before. And that's going to allow the CLI to get all the tokens that are needed for the upload operation. We also can store this information locally in a file. So the next time we call weshare upload, it's going to realize it's already authenticated using that file. It's going to read the token from that file, and it's going to be able to attach the token in the header of the upload request. So before we do that, one thing that I like to do when a CLI application starts to get a little bit more complicated is to break it down into multiple commands. So one file per command, basically, because otherwise this file is going to get massive. So let's do a new folder called commands, I guess. And then inside here, we want to have upload.js, where we're going to move all the files that we already have, all the code that we already have in the current file. And then we also want to do login.js. And just for fun, we're going to have a logout.js that really the only thing that it's going to do is just going to clean up the local cache, so we kind of lose the token locally. Okay, so let's do the upload first. So how it's going to look like? Basically, what we want to do is export default async function upload file path, which is the only argument that this command gets. And here we can literally copy all the code from before. So if we go here, you can see that here we only had one command, and there is an action, which is this asynchronous function file path. Literally, we can take all this code and move it there. I think that's it. And we are going to wire it back in a second. Now, of course, we also need to put all the imports there. So what did we have? We had base name, create read stream, stat, request. Yeah, all of this needs to go in the other file. The only thing we need there is commander. Okay, so now how do we connect that back to our main CLI file? So basically, the easiest thing is that here we just need to pass that function, right? So the easiest thing to do is to just import that function from the other file and just reference it here. So what we could do is import upload from commands and then upload.js. I don't know why my autocomplete and auto formatter are not working anymore. Maybe because I was experimenting with prettier and prettier messed up something. But I think that's everything we need. I think I exported it as a default, so that should be like that. And here we can just say action upload. And now if we run this again, like this, it should, module not found. Why is not found? Did I create, I have a typo there. I have a typo
really?
there.
I didn't even spot
Commands. Sorry about that. Okay, maybe that's why the autocomplete didn't work. Let's try this again. Okay, now it's complaining. Base URL is not defined because this one needs to go in the other file. Commands, upload. This needs to go here. And we might change this. We'll revisit that in a second. So now if we retry this, we get unauthorized. So this is the same behavior as before.
Okay.
Now we want to wire in also the other actions, because right now we only have one command in this CLI. We want to support multiple commands. For instance, like git, that you have, I don't know, git push, git pull, git rebase. It's like one CLI git, but then you have sub commands that you can use. Or similarly, AWS, you have AWS S3, you have AWS EC2, and every sub command is like an entirely standalone CLI application. And Commander allows you to do all of that. You just need to specify different commands. And the way that we can do that is, actually, before doing that, let's super quickly scaffold this one. We want to do export default async function login, and login for now doesn't take any argument. Let's just say console log login for now. And similarly for logout, I'm just going to copy paste because I'm lazy. Right, so here what we want to do is import all of them as well. So we want to import login from login, logout from logout. Okay, so how do we configure different commands? We can say, for instance, program. We can say command login. And then we can say that the action for this command is login, the function that we just defined. Then we can say again, program And we can define other command. So this kind of builder pattern allows you to attach new commands as you go. And every command needs to have a specific action, which is just an async function. So this one can be logout from the other file. And now here, this is exactly as before. Of course,
we have the
here we need to
upload as
say
well?
command again, because right now we only had only one command, and that's kind of the default. Now we want to say that this is the upload command, because otherwise we have no way to differentiate between when do we want to use the upload command or when we want to use the other commands. So what we need to do is still to say command upload, but there is a trick here, which is pretty cool in my opinion. You can say here is default true, which basically means that if you say weshare and the name of a file, as we were doing before, of course, that file doesn't need to be called login or logout, right? In that case, you need to be explicit and say weshare upload that file name. But so most likely that file is not called login.
I think it's
or
worth
logout.
it for the edge case likelihood.
Yeah. But in that case, it's going to realize, okay, you're not logging in, you're not logging out. It doesn't match any other command. So I'm going to use the upload command. And then everything else should be fine. And I also going to move all the help stuff in the, all the help stuff that finish here at the top. I'm just going to say program. This is all the generic information about our CLI. Like the name of the CLI, description, help text. Now, the last thing that we need to do is this parse, which I'm going to put on its own thing, just for clarity. And parse is basically saying, okay, I finished defining all this configuration through the built-in pattern. Now, take everything that you are getting from the CLI invocation and parse the arguments and figure out which commands needs to be executed. So now if we do weshare help, and this is a cool thing from Commander that allows us to automatically build all the documentation, we should see, let me make this bigger, hopefully, that we have multiple commands: login, logout, upload, and help. And at this point, we can also try weshare, if I can type, login, and it's just saying login, logout, and it's just saying logout. And if we do upload, it's saying you need a file name, and we can say, I don't know, thumbnail, PNG. And again, we haven't implemented authentication, so it's just failing on the authentication.
I really like Commander.
Yeah.
I'm sold.
Yeah, it makes it super simple to organize stuff. And there are more advanced things. For instance, we can also use version, and that is going to enable the versioning flag. The only annoying bit is that, for instance, yargs, you can just say version without any argument, and it's going to take the version from your package JSON. I don't think that's possible in Commander.js. And because we are using ESM, we cannot just import a JSON. We need to kind of read the file and do all the stuff ourselves. So I'm going to skip the version for now. Maybe we will add it in a separate PR.
Sounds good. Okay, great. That's good scaffolding.
Yeah, at this point, we can start the login part, which is probably the more interesting stuff. So what do we really want to do here? I actually wanted to do one thing, because I want to leave this thing in a state that people can actually deploy on their own. So hopefully at the end of this episode, you could take all the code we have in our repository, deploy to your own AWS account, use your own domain. Maybe you can use, I don't know, manuel.com, right? Because we have Manuel here in the chat. And then you have your own private file share system. You can use the CLI, and everything should work with authentication and everything else. So in order to do that, what we need to do is to keep the domain generic. So the CLI needs to be able to say, which domain do you want to use for authentication? Of course, we can use the weshare one as a default, but we could make all of that stuff generic. So the first thing that I would like to do is prompt for domain. Then the next thing is to start the device flow and get redirect URL and codes. I'm just going to say for brevity. Open the browser. We will see that there is a package that we can use that actually automatically opens up the browser for the user. And then we need to do poll in the background. And when we get tokens per system in a file, and we will see what are the options there. Then login complete.
Nice.
So this is at high level the steps that we want to implement.
Okay.
Okay, so first thing, how do we do a prompt? How do we ask the user for something?
Console.log. No?
The console.log allows you to print, but not to get input from the user, right?
Yeah. You've
So
got a trick for that, I'm guessing.
Yeah, one simple option could be we just provide an option in the CLI, like you could do -- domain maybe, and or -- URL, whatever, and pass it that way. But I found an interesting package that it's actually very easy to use that actually gives you an interactive prompt, and it can also have a default value. So you just click enter if you like the default value, or you can just type your new value if you don't like that one. And this package is called enquirer. Let me actually install it. So we need to do CLI. CLI npm install save enquirer. That's the one we want to use. And let's import it here. Import enquirer from. And the way that it works is actually fairly simple. Is basically we need to say, let's call it base URL, I guess. So we're going to ask the user, what's the base URL for your deployment? Like in our case, it's going to be https weshare.click.
Okay, so it will include the protocol. Okay, HTTPS.
So the way that you use enquirer, because it's waiting for user input, of course, it's an asynchronous operation. So we need to, it's going to give you back a promise while the user is giving you the input. So we can use a way to say, start this thing, and then await the user to complete the operation. And prompt is something you can configure, and you can specify a type. And here is input just for text. And you can see that enquirer supports a bunch of things. You can have like lists of options, and the user can just scroll through and select the option that they prefer. Input is just like a free form text, pretty much like an input in an HTML form. Name is basically base URL. This is because you might have different fields, like you actually might create like a form and allow the user to input different fields one by one. Here we have only one, so we are just calling it base URL to be explicit, but we could say A and B and just use A and just read the variable that way. At the end of the day, this returns an object with all the fields. That's why we are destructuring here. Okay, and then message, we can say, please enter the base URL of your weshare.click instance or deployment. And then we can also specify a validate function. So for instance, we might want to be sure that this is an actual URL. If it's not a URL, you need to ask the user again until they enter a valid URL. So how do we do that? We can do a try catch and say new URL input. And this one is just going to throw if it's not a valid URL. So we can return true. If it doesn't throw, it means it's valid. Otherwise, in the catch, basically, we don't really need to catch the exception. You only need to return a message that is what is going to be displayed to the user.
Well, okay.
You can find all these examples in the docs. I'm just copying from my previous experiments. Of course, I don't remember all this stuff by memory. But
I like that it's very readable, though. It's easy to pick up this code and understand what it's doing.
Okay, so what's next? Did I forget quotes? No.
Do we need a default, or can we specify a default so that they could just hit enter maybe if they just...
Yeah, that's what we want to do right now.
Okay.
And we can say HTTPS weshare.click. And that should be it. And I think that's it. And just to test if all of this is working, what we can do now is console log base URL. Okay, cool. Let's see if this works. So we do weshare login. It's prompting us. I'm going to make this a little bit smaller. I hope you can read it. But you can see it's saying, please enter the base URL of your weshare deployment. And this is a little bit gray out, but it's saying HTTPS weshare click. Here we can say, I don't know, blah, right? And it's telling us, please enter a valid URL. And I can still edit this. So it's still waiting to resolve that promise because I haven't entered a valid URL. And if I say, I don't know, HTTPS awsbytes.com, which is a valid URL, it did accept that. And you can see here that we have like a green tick. And now the value that we got from that promise is awsbytes.com. Of course, at this point, our CLI action completed, so nothing is happening, but we know how to get input from the user. I hope that is making sense and it is interesting. Okay, so
slick.
Once we have that, what's the device auth URL? It's actually based by convention. In our code, we decided that it's going to be, let's just say device auth URL, but it's basically the base URL and then slash auth, which is the prefix we added to our API gateway for the stack responsible for authorization. And then we have device auth, authorization. That's the full URL there. So we can do a post request there to basically start the flow. Okay, so we used before this client undici, which was, we saw it in a few episodes ago, which is really neat because it's part of the nodejs foundation right now, and it's actually even more performant than I think that the default HTTP that is in nodejs. But it's in general, it's a very modern client that has async await, and it's very. They are even trying to standardize it with fetch. I'm not really sure what's the progress there, but eventually, if you know the API for fetch, you should be able to use undici with the same API. So you can import this thing called request from undici, which, by the way, means 11 in Italian. You can tell that whoever started this project is Italian. Okay, so
what has 11 got to do with HTTP? I wonder.
I think because it's HTTP 1.1.
Okay.
And I think it was I think the documentation says it was a reference to Stranger Things or something like that.
Okay. Okay, I don't get the reference.
Yeah, there is a character called 11, or undici, of course, in the Italian version. Okay, so we can do this request, device auth response. We can await, request. And the thing that you need to pass, as you would expect with any other client, is device auth URL. And then I'm realizing that the Copilot is strangely quiet. I think it's not even started.
Yeah.
So today
you're having to do everything yourself.
Yeah, I feel like I don't have any superpower. Okay, we can pass headers and we can say accept application JSON. This is stuff that Copilot would have guessed. We can also pass a user agent just for good order. Maybe we can put that in the logs later. CLI, and that's
Great.
literally it. We don't need to do.
Yeah,
This is enough just to start the
back.
response. Yeah.
Yeah.
Now, the interesting thing about this client is that it makes a difference between receiving the headers and receiving the body of a response. So this promise here, this request promise, is actually resolved when you finish to receive the headers and the status code. So even before it parses, receives all the entire body. And that body is actually something that if you want to consume it as a stream, because maybe it's a large body, you can also consume it as a stream. So the response is actually just this first object. If you really want to read all the response body, we need to do another await. And it looks like this: const device auth resp body. And this is similar to fetch, by the way. Fetch does the same. Device auth response body.json. There are also this kind of helpers. You can say JSON text or stream that allow you to also parse that response body in a specific way. Now at this point, I will just do a console log and say device auth response body. And if everything works, we should see the response that we were seeing before in Postman when we were calling the device flow. And which basically means that we have a URL where to go, we have a user code, we have a device code, and I think we also have an expiry time.
Yep.
So let's see if all of that works. We can enter weshare click. And yeah, this is basically what we get.
Perfect.
So theoretically, I could be going to this URL and log in. I'm not going to do it now because in theory, we need to implement the poll mechanism before we do that. Yep. Otherwise, nobody's going to be listening for the session to be completed. Okay, so what do we do next? Let's see.
Well, we poll, I would say, right?
Yeah, there is a nice thing I would like to do first. So
yeah,
we need to do actually two things. We need to tell the user, go to this URL, but we can also, as we mentioned before, we can also use a library called open that can try to automatically open the browser window for the user. So the user doesn't even have to think, okay, let me read this, copy paste, open a browser, go there and do all the stuff, but it's automatically going to open a browser window in the right URL. So let's do npm install save open. And another thing that I really like, it's just a silly thing, but I think it makes a nice difference when you build CLI application, is like to have a small spinner that says, by the way, I'm waiting for the user to complete the authentication in the browser. And that's called, that there are so many of these libraries. One that I really like is called Aura, I think. Let me look into my notes. That's the one. Yeah. And yeah, we can see that that allows us to show a spinner, and we can basically show a small animation that says waiting, 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 and spinning. And then we have an API that allows us to say, okay, this action was completed when we finish polling, or maybe we timed out and this action is failed. So we have a nice visual feedback to see what the CLI is trying to do behind the scenes. Okay, so let's see how do we use both of these things. So first thing, we need to import open, and I think it's just open from open, and import Aura from Aura. So quite straightforward. Now, how do we do all the stuff? Okay, what we could do is, first of all, just in case that the open thing doesn't work, what we can do is just tell the user, login, please log in at, and the URL. So device auth response body dot verification URI complete, I think. And view it here. Yeah, this one.
Perfect.
I spelled it correctly. And then we can actually take all of this again. And we can just say await, open, and all of that. And what open does is basically smart enough to understand that this is a URL and try to open a browser. But this library can also open other applications. So you could also build it to open, I don't know,
A file.
any other, or even other programs, not necessarily a browser. You could open, I don't know, Photoshop or whatever, if it makes sense for your own CLI.
Perfect.
Cool, and it should open your default browser and all that kind of stuff for you.
What happens if it can't?
If it can't, that's a good question. I think it might just throw. So maybe it's a good thing to wrap it in a try catch, just in case. So for instance, if you don't,
dumb terminal
exactly,
that doesn't have a browser, it'll. We can tell them you got to do this yourself.
And we are telling them anyway here. So
we're telling them anyway. Yeah.
Okay, then the next thing is to create this spinner. So how do we create a spinner? It's actually quite easy. You just say ora, which is the name of the library, waiting to complete the
Is this also Italian, ora? Is this like...
this one is another library by Sindre Sorus, one of the guys that you've probably seen 1 million times on NPM, because he created probably 1/3 of all the packages. I don't know. It's an Italian name. Ora means now in Italian, but there is no reference to that in the README. So I don't know if it's just coincidence or maybe it's an actual Italian reference. If somebody knows, let us know in the chat. Okay, and then at this point you can just say start. So this is like an object that has a bunch of. It's gonna print in the console. But then you can retain a reference to this object to change the status of that print. For instance, you can say complete, you can say failed, and it's going to actually display different icons and different things if you change the state of that prompt. And actually, we can run it again, and we should see. We are not polling yet, so we should just open the browser and see the spinner, and we shouldn't be able to complete it yet, but everything else should be working. So let's try again. So enter the URL, weshare.click. It did open my browser, but in another window. So let me see if I can bring it here. Yep. So here I have this browser open. So technically I could complete my login here. I'm not going to be doing it right now. But you can see that there is here a little spinner. I don't know if you can appreciate the animation.
It's nice. Yeah, it's very subtle.
And we can actually control the state of this. So if you complete it, it's going to become like a green tick. And I think if it fails, it's like a red X or something like that. Cool. So I'm going to clean up a little bit. We can remove this one, and we can remove the base URL because we saw that all of this works. So now we started the flow for sure here. And now what we want to do is poll in the background. Open the browser here, and we poll in the background. So we need to build the request for the first polling, and then we need to somehow to do it in a loop until it succeeds or it expires. So let's see how can we do that. I guess that one simple way could be let logged in equal null. Maybe that's an object where we store the response. And then we can say while not logged in, we keep looping. And
are we imagining that this is 3 states, like null, true, and false? False being failed or something to that effect?
Good point.
I'm just wondering why you initialized it as null instead of false.
I think we can do a break if it fails in some way.
Okay, yep.
Yeah, I was thinking that here we can just have an object and reuse it, but to be fair,
Very good. Yeah,
Yeah, because we're going to be
curious.
referencing that object outside the while. That's mainly the reason.
Okay. Let's see how this unfolds.
I'm realizing that also we need an interval. So we need to do two things. We need to, so before we actually check it, it doesn't make sense to check straight away because most likely the user is not faster than the CLI to get into this while loop and enter the from. So it makes sense at the beginning of the while to wait for the interval. So we can import from node set timeout from node timers promise, I think, if my memory is correct. Let me check in my notes. Promises, that's, yeah, I always forget that it's plural. And basically with this one, what we could do is saying await set timeout. So it's like a different incarnation of set timeout. Rather than using a callback, it returns a promise. So you can simply await that timeout. It's like a sleep in Python or other programs, but it's actually asynchronous. So we can do set timeout, and we need to specify how long. And we have that information from device response auto response body dot interval, but because this is in second, we need to multiply by 1000. So sorry, the interval is in second here. Set timeout takes millisecond. Okay, so this is just gonna wait for 1 second or 2 seconds, I think, is the what we received back before checking anything. What's the actual check? So we need to create a bunch of things that I think we can create just outside the loop because they're always going to be the same. So what do we need is the token URL. I'm going to call it, which is basically the base URL again. And then /auth/token. And then what do we need to pass? I don't know if we spend a lot of time looking at that in Postman, but it's
We've
basically
glossed over it. Yeah.
Yeah, the body of this request is a string encoded as a query string, which is a little bit weird in my opinion, but it's something that it's actually quite common in the OAuth protocols.
Yeah.
That
It's old-fashioned, isn't it? It's from multi-part form uploads or something.
I don't think it's even a multi. It's just a form URL encoded. Yeah, it's not even multi-part.
Form URL encoded.
Yeah.
Yeah.
So I mean, it's not a big deal. We can do it, but it's not a JSON as you would expect for most modern APIs. So one way to create that is we can do token payload, and we can use query string, which is another library that exists in Node.js core. So we need to import it. Import query string from called query string. And this query string basically allows you to take a generic object with key value pairs, and it's going to automatically convert it into a URL properly encoded query string parameters. So let's see. What were the parameters? I cannot remember, so I need to check. Okay, the function is called encode, and then we can pass an object, and the two parameters are grant type, which needs to be a very specific string that I'm just going to copy paste, but you can
A very
find it.
specific string that you wouldn't want to try and type manually.
Yep. You can find it in the standard RFC that we linked last time. And then device code, guess what? It's the device code that we got from the response before, like the long string that you can see here in this particular case. So we can do device auth response body, device underscore code. So this is where we need to send it, and this is the body. Of course, there are also headers, right? Let's see, const token headers, I'm going to call it. And what we need to send as headers is accept application JSON, because the response is actually going to be a JSON. So we are saying, I'm sending you something in a specific format, but what we want back is actually JSON. And the specific format that we are sending is content type. And this is application x www form URL encoded. And you can probably hear the ice cream van music in the background.
But you can't stop now to get an ice cream. You got to keep going,
No,
Luciano.
I need
Keep
to
coding.
faster, yeah, so I can get my ice cream later. So we share the click CLI. Cool. That's basically it. Okay, so now we have everything we need to do a request. We have the URL, we have the body, and we have headers. And we know how to do a request, which is basically going to be, let's see, await. Actually, let's call it const token response. Await request token URL, it's all uppercase. And then method, again, this is a post, if I remember correctly. And then we have headers, which we just created, token headers. And then we have a body, which is token payload. We call it payload, token payload, and token headers. Cool. Okay, so at this point, what we can do is, again, we don't really get the body as a response. So if we really want to get the body, we need to do token response body, await token response body, response.body.json. And now what we can do is just a console log for now. So we can see this in action. But of course, we will need to check this response body to decide, is this still pending? Is it timed out? Or is actually successfully authenticated? These are the three outcomes that can happen. And we need to manage them and decide what to do next. So this is still waiting to complete. You can see that still spinning. We can cancel it and run it again. We share login, enter the URL, open my browser again in another screen. So trust me. But you can see that it's starting to poll in the background. And you can see this error code authorization pending, which basically means it's kind of an error because the authentication is not complete yet, but it's an expected error in this case, which just means be patient, keep waiting. The user is not done yet with the authentication. Okay, so I'm going to cancel this.
It's not really an error. I guess they're just trying to build on the existing OAuth access token spec. So this is the way of putting a pending state in, is just to use the error mechanism. Yep.
So another thing that we don't see right now, but trust me, please, is that when we actually going to get the successful authentication, the status code is going to be 200. So one way that we can start to create all these three conditions to decide what to do next is basically by checking that token response dot status code is equal to 200, not 2000. So when that happens, basically we can say logged in, our object is equal to the token response body. Okay. And this is going to allow us to break out of the loop and save this information so we can use it outside. And we can also say spinner.succeed, which basically changes the status of that spinner. And you can also specify a message, login successful. Then we have an else. And this else is actually, we need to be specific because we might have we might have the case if it's authorization pending, everything is fine. We just need to wait and go again through this loop. It's going to wait 2 seconds and then do this request again. So technically, we don't need to do anything there. What we want to be aware is if the error code is not authorization pending, then there is something weird there. Most likely the authentication expired, but maybe there is some other form of error. We just want to, at that point, to just stop print the error and stop the CLI. So what I'm going to do here is just check token response body dot error code. If it is different from authorization, I'm going to copy it from here because I cannot spell authorization. So in this case, what we want to do is spinner.fail. And this is going to show like a red X with a message, login failed. And we can say, we can actually show the error. So let's just do like this. And we can say token response body dot error code. And then we can just do process.exit1, which is just going to stop the entire CLI with an error. If none of that happens, basically we are at the end of the loop. So it's just going to go again and do another loop. And what I'm going to do just for us to is console log logged in. So now we should be actually be in a position to test our CLI. And the only thing that we will be missing is persisting the information at that point. But most of the work is done. So I'm going to delete this one because we know it's working. Okay, so the only thing we need to do is to try again, log in, enter this. It's opening a window, which is not this one. So I'm going to get the other one here. Okay, let's see if I think this one is the right one. Sign in. Thank you. You can return to the weshare client. Let's see if that's true. And here we have, we can see that the spinner turned into login successful. And this is the logged in response that we get. And we have an ID token. We have an access token and a refresh token. And we also have expiry and token type. So this is all we need to be able to do a request. I'm just going to show you the same thing that Owen showed you before. If I can get this token here, we can just do JWT info, this token, and JQ. I don't know what's happening there. But yeah, you can see that basically this is the content of the JWT, Cognito username. You can see my email. You can see verified true, and a bunch of information about the user, which matches the user that I just used for logging in. In reality, the token that we want to use for the request, if I remember correctly, is the access token, not the ID token.
Yeah, well, we could use the ID token to say hello or send them, identify them if we wanted to personalize the front end, I suppose. But other than that, it's probably not that useful right now.
Yeah, I think the access token also contains something about the user. Let's actually double check that because I'm curious. So JWT info is, I love that it doesn't fit the characters and it's messing up everything. So, okay, it doesn't give us a lot of information. Like there is information there, but it's just IDs. It's not information you can simply take and print. So you'll need to query Cognito to actually, for instance, username is probably just the ID of the user in the Cognito user pool.
Yep.
I'm going to assume. Yep. So you will need to query Cognito if you really want more information about that user.
Okay.
But other than that,
that's the token we need anyway.
Yeah, that's the token we need. Now, the last question is, how do we persist this information? Because now the application has stopped. So we just, all that information was in memory, we just lost it. What we would like to happen is this information to be persisted somewhere in the file system. And then next time we run the upload, the CLI should be smart enough to realize, oh, wait, I already have a configuration file that contains my token. I'm just going to use this token. I assume the user did the login before trying to upload a file. And this is not too different from the AWS CLI, for instance. I don't know if you ever looked into the configuration files of the AWS CLI or the credentials files, even better. What you do, you will do AWS login, and then you have a prompt, you go through all the configuration, it does the login for you, and then you go inside your user folder, .aws/credentials, you open that file, and you have all your secret and token ID there in clear text. We might argue that this is not the most secure thing ever, because if somebody manages to steal that file, they're basically stealing credentials. So it's not really encrypted or, I don't know, saved in a keychain or in a vault kind of thing. But for now, we assume that this is good enough, and AWS is doing the same, unless you have a more sophisticated setup. One good thing is that, of course, we are not going to implement all this stuff from scratch. There is a library that can do that. And again, it's a library by Sindresaurus, not surprisingly. And this library is called just config, so very easy to remember. So let's install the library first. And the way you use config is actually super easy. So the idea is that you just say config.set, for instance, some info. You can say some value. And what happens is that it's creating, actually, sorry, I'm remembering this wrong. You need to create a new config first. I think it's new config. I'm going to check my notes in a second. But this is basically the idea. When you create a new instance, it's actually using some conventions based on your operative system to decide, okay, given the current application, where should I store a configuration file? So it's actually looking into your package.json, using that name as a unique reference to the project, and then it's creating in the file system generally where your operative system stores configuration files for programs, and it's going to create an entry there. It's going to create a path with the name of your application. I don't know if it uses even the version. And then it creates a JSON file there with all the details that you can configure this way. The other cool thing is that you can do a bunch of additional things that we're not going to be doing. I'm just mentioning them because I think it's cool. It even supports migrations. So if between a version of your CLI and the next, you decide to change the structure of the configuration file, you can even have a migration script that automatically updates your configuration file before you actually start to use it. And another thing that you can do like obfuscation. It's not really encryption, but you could pass a key that is gonna, rather than having a plain JSON that anyone can easily read, it's gonna keep it encrypted with that key. Now, I call it obfuscation because the source code is gonna be in the same laptop anyway, so you can probably find the key for decrypting that file, but at least there is an extra level of security that people need to go through before they can actually steal your tokens. So we might even try to enable that to see what it looks like. Okay, now one thing that I like to do is to create another file and call it config, where we actually initialize all of that. We have a question here. Oh yeah, very good point. Okay. I think I got it wrong. Yes, you are totally right. There is another one called config, and I did install the wrong one. So thank you for saving us a lot of time, Paul. So I'm going to try to fix my mistake.
That was a sharp observation from Paul.
Thank you so much. npm I save conf. So yeah, thank you. Okay, so how do we use this? Import conf, not config, from conf. Another thing you will do is to define a schema in following the what is it called, the JSON schema? Specification.
Okay.
And this is only useful it kind of does a small validation when you do a set when you call .set, it's going to make sure that you actually have defined that property in advance and it conforms the type. We don't really need that, but because I did it before, I'm just going to copy paste this in here. And you can see that what we want to store is the base URL, because of course we also need, if the user specifies a custom base URL, we also want to remember that base URL because we're going to be using it for the upload as well. Then everything else is just the tokens. We don't really need to store the ID token. We only really need the access token and the refresh token, but I decided to store everything just in case for now. And then the last thing we want to do is export const config equal new conf of schema. Now we can go back to our login and we can import, this time we can import config from slash config.js. If I can type. No, I cannot type today. Okay, so let's see. What are we missing now? Okay, at this point, we should be able to just say at the end of our login, I'm going to delete all of this. I was just using for demonstrating the idea and I got the package name wrong. But at this point, what we want to do is just to say config.set base URL and base URL. Config.set ID token and logged in dot ID token. I'm going to copy paste because I'm lazy. Then we have access token. And then we have refresh token. And that's all we need to do. At this point, we're done. Now there is also, I'm going to console log config so we can,
All right.
It's going to give us a bunch of details, for instance, where the file lives. So we can actually see that there is actually a file that gets created and the content of the file is a JSON that contains all these properties. Okay. Get
I guess it handles like operating system specific locations. Like on Windows, it's going to be under application data,
like,
username,
exactly.
all that. Yeah, cool.
Yeah, that's why I actually want to show that because I think it's pretty good. Okay, let's do the login again. Not this one. Weshare login. We like weshare click. Is triggering the browser in another window. Believe me, it did actually automatically complete because I was already logged in. So we can see here login successful, and you can see path here. This is where the configuration was created, and it's in my library preferences, which is pretty typical for Mac applications. It did figure out that the package name is called weshare from the package JSON, and then it also added this -nodejs for whatever reason, and then config JSON. So here what we could do is cut all of this JSON, JQ, and you can see that it contains all the properties that we defined. So this seems to be working as we want. One quick thing that we could do, just for fun, is in the prompt where we were saying what's the default thing, we can say conf.get base URL. Is there an underscore? There wasn't. Or this. So basically, if the user already logged in I don't know, luciano.com, next time that they do a login, is gonna automatically suggest that luciano.com as a default.
Nice. This is really elegant.
Okay, now at this point we can quickly do the logout, which I think will be super simple because what we want to do is just import config from config.js. And inside the logout, we only want to do config.clear, which is literally going to delete everything. And then console log.
Perfect.
You have been logged out or something like that. So let's just test that. We share, actually, let's just do, what was the file? This one. You can just say ls, and the file is there. If we run weshare logout, we've been logged out. And if we do this, oh, the file is still there. That's interesting. Is it going to be empty? Let's figure that out. It is empty though.
It's empty.
So it's retaining the file for whatever reason, but it is empty at least. So we are actually erasing the credential from the machine. Okay, so I think there is one more thing to do, which is actually change our upload script to use these credentials. And if the credentials are not available, because we cannot read them from the configuration, maybe we can say, sorry, I see that you are not logged in. Please run this command to actually log in. So let's go to the upload command. We don't need this base URL anymore because this is going to be part of the configuration. So let's remove that. And then what do we need to change? Let's see. What we could do is here, even before doing anything, we can see if the user is logged in. So we need to import the config. Import config from config.js. So at this point, we can do base URL equal config.get base URL. And this is where we can check. If not base URL, basically means that you never logged in. We could also get the access token, to be fair. So I'm going to do this for now, access token. And here I want to get the access token as well. I think it was with an underscore. So here what we can do is...
You're missing an S in access token on line 10. Since your editor isn't telling you anything these days.
Log.
I'll be your co-pilot.
Thank you. Looks like you need to log in. Please run, I don't know, /n weshare login. And we can do process.exit 0 or 1. Is this an actual error? What do you think?
Oh.
It's more of a suggestion.
You can't, upload is failing. I think it's a non-zero error.
Okay, let's say 1. Yeah, fair enough. Like it didn't really fulfill your expectation. Yeah. Okay, so at this point, if we try to do weshare, I don't know, this file, package.json, we seem to like to upload the package.json. Let's see what happens. It looks like you need to log in. Please run weshare login. So half of the work is done. What we need to do next is to get the share URL. And this time is going to be base URL and /share. And now let's see what else do we need to change. Do we call it share URL? We call it here base URL.
Right. Yeah. Cool.
Then everything else I think is okay. We just need to change here in the headers and pass the authorization, right? So we need to say authorization, and the syntax is bearer and the access token. Pretty standard JWT authentication. And I think that's everything we need to do at this point. Everything else should work as before. So what we can do is to log in again. So weshare login. Ooh, what happened? Base URL. That it didn't like
we have
that.
to import conf, do we? Have you
I
imported
thought
config?
I did. Oh yes, you're right. Config
Config.
was just a typo. Okay, so login again. Weshare click is doing all the stuff behind the scenes. My browser should be already authenticated, so login successful. Now we can do weshare upload, which we may or may not be explicit by specifying the command. Let's go and upload MVP dialog PNG. Let's see if it works. Cool, it's giving us a URL.
Excellent.
Let's see if that's really giving us the file that we want. It's downloading a file, and this is our MVP diagram. So
Nice.
everything seems to work. I don't know if there is any question from you or from people in the stream.
Yeah, I can see all the questions. I don't know if we have one right now. Maybe people can type them if they think of them, or maybe some next enhancements that you think we could make. Do you know what I thought of, Luciano? And we probably don't have time to do it, but I did a quick Google, and there is a npm module for QR code on the console, so it would make it easier if you want to authenticate on a different device.
That's really cool. I'm already looking forward to trying that. Good catch. Another thing I was thinking that's actually probably more important than a QR code. Right now, we are not refreshing the token. So if we commit and release this particular version of the CLI, what's going to happen is that eventually your token is going to expire, and we are not automatically refreshing it for you. We could do that because we are also storing the refresh token. So technically, the CLI could be smart enough to say, okay, I see that the token you're trying to use is expired when I try to do the upload because I get I guess you get a 400. It's
always a 400.
It's a 400.
Sorry. Which request was that?
When you call the upload with a token that is expired.
Oh, okay. Yeah, that's a good question. It's not a 400 in that case. I don't know if it's a 401 or a 403.
Yeah, you get a status code that is like an error. So what we could do at that point is see, okay, your token is expired. Let's try to refresh it and try again. And also update the configuration with the new token. So we could implement all that business logic, but I think for today we're going to leave it. And what you could do if you see a failure, meaning that the token is not valid, is just log in again. And at that point, you're going to get a fresh token. Does that make sense?
Yep. Yeah, I think that's good. But I think as a file sharing utility now, it's actually production ready because at least we've got authorization. We can publish this npm module to npm. We can distribute it to people, and people could actively use it. Of course, people can't self sign up, but that's a good thing because it means you can control your own private file sharing system.
Yeah, which basically, I don't know if we showed this. I think we showed it in a couple of episodes ago. But basically, from Cognito, either from the web UI or through the CLI, you'll need to manually add the users that you want to allow to log in. Yep. So that there is this extra step. We'll try to document it in the README.
Yeah, you can also use the AWS CLI for that. If you want to create users or create a load of users, yeah, you could do it that way. But I think you get the idea, right? Because we're using Cognito here, and you could also use federation with Cognito user pools. So you could also use like a SAML provider or a Google account provider to actually do that login too. So there's lots of possibilities to improve that.
Yeah, another thing that we mentioned at some point, but we haven't implemented yet, is, for instance, to expire objects in S3. Because most likely you are going to upload something, give the URL to somebody else, and they will download it in, I don't know, a couple of days, a week, whatever.
Yep.
You don't want to keep paying forever for that object, especially if it's a big one. So probably makes sense to also implement some expiry policy. And in S3, all of this stuff, it's relatively easy. We just need to write a little bit more configuration.
Yep.
So also keep in mind that PR are most welcome. So if you if you find other ideas that you think are worth implementing, definitely send us a PR and we'll be happy to discuss it and maybe even show it in the next streams.
That would be really welcome. Yep. I'm pretty happy. I'm really impressed with that, how elegant and smooth this CLI fits together. Those modules you showed, most of them I'm seeing for the first time. It's just really useful information for the future.
Yeah, I actually find that Node.js has a very good ecosystem for CLI applications. And not surprisingly, a lot of tools, common tools that you use every day, like even the serverless framework, for instance, are written in Node.js. So yeah, I think that's just another testament to the Node.js ecosystem as a whole.
So I think our plan, right, just for these episodes, thanks very much, Paul, for your comment there. It's really great that you were able to watch. I know a lot of people are watching not live as well, so even though you're not watching live, thanks very much for coming and checking out the videos or the audio later. Our plan is to go back to some on-demand episodes for a while, and maybe we can have a discussion on some of the topics we covered, but just go back to some of the traditional episodes. But we'll definitely return, I think, for some live coding. I think we've learned a lot with doing this, both of us. We've also, not just about the services and how to use them, but also just about the challenges of live coding and trying to fit everything into the right time. So if when we do more episodes, we're definitely interested in your feedback. So let us know if you want them to be 30 minutes, 60 minutes, and how you think we can pack them in. So are you happy just for us to show you pre-canned code, or do we just try and reduce the scope of what we're trying to do? Is there anything else we need to say before we wrap up?
No, as usual, just send us any feedback or comment. And if there is, for instance, any project idea that you would like us to explore next as another idea for live streams, definitely really curious to hear what you're thinking. So I'm not going to promise we're going to implement it, but we're definitely going to consider it.
Awesome. Okay. Thanks everyone for joining again. It was great having you all here, and we'll see you the next time on AWS Bytes. Bye-bye.
Bye.